Hello, geometry folks, and welcome to Angles and Circles. So we're going to continue our journey with circles. You're going to need your chart that I gave you in class today, and we're going to take a couple of notes on that. And then you're going to need your notebook because you're going to have to use put some examples in your notebook. And then you're going to need a pen or a pencil and a calculator, and we'll get started. So yesterday we talked about the central angle and how the central angle is the angle that has a vertex at the center of the circle. And what we talked about yesterday is that that angle, or that central angle, is exactly the same as the degrees of the arc. Okay, so if the measure of the central angle is 30, then the arc degree is also 30. So we talked about that yesterday. So what we're going to do is go ahead and put that on our chart today. So what we talked about is that central angle and the relationship between that angle and the arc. So if I were to draw a center and draw two radii, okay, the angle and the arc would have equal degrees. So the central angle degrees is equal to the arc degrees. That's what we learned yesterday. Now I just want you to go ahead and put that in your notes because that is something that we want to be able to refer to. Now, we talked about that yesterday. That's what we talked about, how we had the angle in the middle and we got this little funny looking bear. He was in the middle of the circle. Now what we're going to talk about today is the bear being moved and it not being in the center. It's still inside the circle, but it's moved away from the center, and how that angle will relate to the arc. That's what we're going to do today. All right, so that's called an inscribed angle. So we're going to talk about that inscribed angle and how that angle, when we inscribe the angle, then what happens is we have an intercepted arc. Because what an inscribed angle is it's two chords, or we could really just say two rays, okay? If I extend it, it's a ray. And what happens is it intercepts the arc of the circle. And so we're going to try to figure out what that relationship is between the inscribed angle and the intercepted arc. So if I look at this, how many degrees is the intercepted arc? Well, we should be able to figure out how many degrees the intercepted arc is from yesterday, because what I have is a diameter. So I have a diameter AC, and the arc goes from one side of the diameter to the other. We know that a diameter gives you an arc of 180 degrees, a semicircle, right? That's from yesterday. So the intercepted arc would be 180 degrees. Now, what would be the inscribed angle? When I look at this, I'm not really sure, but I do know that it has to be less than 180. And if I use my reasoning skills, I would say that it almost looks like a 90-degree angle or a right angle. But I'm not sure. So let's go ahead and see if we can figure that out based on the formula that we're going to be given. So make sure you have this written down in your notes, that the measure of an inscribed angle, oh, there we go, it equals half the measure of the intercepted arc. So the intercepted arc is half of the inscribed angle. So the angle inside is equal to the arc divided by 2, okay? So now what we know, oops, I didn't mean to write right there. I'll erase that and move it over. So now what we know about the last slide is that the angle inscribed for a semicircle will be a right angle. So that would be 90 degrees. Okay, so now you can go back and put that as a 90-degree angle. Okay, so again, the angle inside the circle is the arc degree divided by 2. That's another way we can write that. So let's go ahead and write that on our note card where we have 2 chords. Because what we have is we have 2 chords giving us an inscribed angle, okay? And we want to talk about how that relates to the arc. And remember, the angle is equal to the arc degree divided by 2. So the angle degree would be equal to the arc degree divided by 2. So that's what we want to talk about today. So we're going to do 3 examples, and then we'll come back tomorrow and practice more of these. And then we'll spend the next day working on other circle information. So here we go. Let's find the indicated measure of circle C. So the first thing I want to do is I want to find the measure of angle D. So if I look for measure of angle D, there's D, and if I look for the intercepted arc, I know that the intercepted arc is 100. If I divide that by 2, the angle would be 50 degrees. Okay, now let's find the measure of arc AD. Well, I know that arc AD is right here, okay? The angle that it correlates with would be 35, so 35 would equal arc divided by 2. If I solve this for the arc, I could put an x there if I wanted to, multiply both sides by 2, and I would get x equals 70 degrees. So this would be 70 degrees, and angle D would be 50 degrees. All right, make sure that you have that example in your notebook. Here's another example. If I have this picture with some angles J and K, I want to talk about what the intercepted arc is for angles J and K. So angle J is there, and its intercepted arc is LM. And there's angle K. Well, guess what? Its intercepted arc is also LM. So the intercepted arc is LM for both of those angles. Okay, what's the intercepted arc for angles L and M? Okay, let me get a different color here. The intercepted arc for angles L and M, so here's angle L. The intercepted arc would be, for that one, would be KJ, or JK, however you want to say that. And angle M would also be KJ. So now my question to you, would you be able to make a conclusion based on what we just went through? Well, here's our conclusion. If 2 inscribed angles of a circle intercept the same arc, their angles, oops, typo, sorry. Their angles are congruent, not their angels, but their angles, I'm sorry. Sorry about that, are congruent. So if 2 inscribed angles of a circle intercept the same arc, then their angles are congruent. Okay? So that is a conclusion we can make, that J and K have the same degree. So angle J and angle K are congruent. We can also say that angle L and angle M are also congruent. Let's find the measure of KN, the arc KN, and the measure of angle KMN. All right, so let's go ahead and find the measure of KN. So looking for the arc KN, we know the angle inscribed is 52. So 52 equals x over 2. So x would be 104 degrees. So the measure of Kn, arc Kn, would equal 104 degrees. All right, now let's find the measure of angle KMN. Angle KM, MN, oh looky there. KMN intercepts the same arc, therefore the measure of KMN will equal 52 degrees. That'll have the same degrees because L and M will be congruent because they both have the same intercepted arc. Okay, so that's all I have for you today. Thank you for taking good notes, and we will be back to practice this.